Okay, let's dive right into this masterclass explainer where we are going to completely decode the examiner's mindset so you can conquer the Cambridge AS and A-level Mathematics 9709 syllabus. Listen, I want you to think of tackling this exam like being a master chef in a high-stakes, high-pressure kitchen. You can't just throw a bunch of random ingredients into a pan, turn up the heat, and hope for a Michelin star meal, right? You absolutely need a recipe for success. In this scenario, you're given data and your formulas, those are your raw ingredients. That's your evidence. Your systematic problem solving, your logical step-by-step working out, that is the cooking phase. That's the pure analysis. And finally, your formatting, your perfectly drawn loci, your final evaluative checks, that's your plating. It's how you present your masterpiece to the examiner. Today, we're focusing on one of the most notoriously tricky complex dishes on the entire Cambridge menu: complex numbers and Argand diagrams. Now, I see this all the time. Picture two students taking a past paper. Let's call them Alex and Sam. Alex is the kind of student who just overloads the page with raw mathematical facts, dumping every formula they know onto the paper, but with absolutely zero analysis. It's a mess. Then you have Sam. Sam rushes through, panics at the sight of an Argand diagram, and completely misses what the command words are actually requiring. They both end up with a paper covered in red pen marks. We are going to fix that today. I am thrilled to walk you through this because understanding the examiner's palette, what they are literally looking for when they grade your paper, will completely transform the way you approach your revision.
Take a look at this quote. It's directly from a senior Cambridge examiner, and it brilliantly illustrates our core focus today. Mastering Argand diagrams is your absolute direct path to top marks. You might be wondering, why is this specific topic the great divider? Why does it separate the B students from the A-star students? Well, it's because Argand diagrams force you to do something incredibly demanding. You have to combine pure algebraic manipulation with geometric visualization. It is not just simple number crunching anymore, it's spatial reasoning. You are literally translating algebra into a physical space. If you can master how to seamlessly transition between the algebra of complex numbers and the geometry of the Argand plane, knowing when to use an equation and when to sketch a locus, you instantly elevate your entire mathematical profile. This is the secret sauce. This is what takes you from struggling to confidently securing those top-tier grades.
So here is our roadmap for the explainer today. First, we'll cover the A-star difference. Second, we'll dive into the technical methodology framework. Third, we're going to look at problem solving and evaluation. And finally, we'll wrap up with the top examiner warnings.
Let's move straight into Section 1, the A-star difference. We really need to see how the assessment objectives are actively targeting very distinct cognitive domains.
This is a massive, absolutely critical question to ask yourself. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so why is unfamiliarity so terrifying in an exam? It's vital to realize that Cambridge doesn't just test whether you can memorize a formula sheet. They are actively probing different levels of your brain. Knowledge is simply knowing the formula for the modulus or the argument. Application is using it in a basic, standard question. But analysis? That is the A-star territory. That is where you synthesize entirely different mathematical ideas to navigate through completely novel problems. When you step into that exam hall, you are not going to see the exact same questions you practiced in your textbook. The examiners are clever. They intentionally wrap familiar concepts in totally unfamiliar contexts. This is exactly where our friend Sam from earlier panics. Sam sees an Argand diagram question combined with a tricky inequalities problem, or maybe a demanding locus of points they've never encountered, and they just freeze. They fail to recognize the basic ingredients just because the packaging looks different. Your ultimate goal is to develop conceptual flexibility. You need to be able to see right past the disguise to the core mathematics underneath.
Now, what's really interesting about this slide is the paradigm shift it represents. The academic benchmarks for the 9709 syllabus demand logical, structured reasoning that prioritizes deep analysis over simply skimming a wide range of topics. Superficial breadth is like Alex, knowing a tiny little bit about everything, but not possessing the depth to actually solve a complex multi-step problem. Analytical depth, on the other hand, means you thoroughly understand the geometry of complex numbers. To get this depth, top students use something we can adapt for math called the Peel framework. Point, evidence, explanation, link. Your point is identifying the mathematical feature, like stating, this equation represents a circle. Your evidence is the raw mathematical data extracted from the question. Your explanation is your step-by-step algebraic manipulation or theorem application. And your link is tying that final calculated value directly back to what the command word asked for.
You don't just memorize that a certain equation makes a shape. You understand the mathematical why behind the shape. You know exactly why the locus of the absolute value of z minus z1 equals the absolute value of z minus z2 represents a perpendicular bisector. That is analytical depth.
Moving into Section 2, the Technical Methodology Framework. We have to look at how strict presentation conventions are literally the foundation of your success with Argand diagrams.
Remember our MasterChef analogy from earlier? Well, this is where your technique really matters. You could have the freshest, most expensive ingredients in the world, but if your knife skills are sloppy, the dish is going to fail. In the Cambridge Mathematics syllabus, your mathematical knife skills are your procedural frameworks. The absolute crucial point here is that marks are awarded for the process. Your systematic analysis and your evidence-based reasoning are what the examiners are truly grading. This is called the method mark strategy, and let me tell you, it is a complete game changer. Imagine Alex and Sam are both rewriting their flawed answers right now. Let's say they are solving a complex equation to find the roots. Right at the very end, they make a tiny, silly arithmetic error and mess up a plus or minus sign. If their answer is literally just that final wrong number sitting at the bottom of the page, they get 0, a big red cross. But, and this is a massive but, if they laid out their process, if they showed the clear application of de Moivre's theorem, if they clearly extracted the modulus and the argument step by step, suddenly those red marks start transforming into green check marks. The examiner can and will award method marks for the procedural framework. You are essentially proving to the examiner that you know how to cook the dish perfectly, even if you accidentally dropped a tiny pinch of extra salt at the very end. That is the blueprint for math success.
To effectively apply this method mark strategy, you absolutely must develop professional skills. You have to rigorously adhere to these 4 strict procedural conventions in every single answer. This is the plating phase. First, proper headings. This means making it incredibly obvious which part of a multi-part question you are answering. Don't make the examiner hunt for your work. Second, correct terminology. Use precise mathematical language. Refer to the real axis and the imaginary axis. Please don't just call them x and y when working on an Argand plane. Third, appropriate formats. This is vital in dealing with complex numbers. You need to know exactly when to leave your answer in exact polar form versus Cartesian form, and that entirely depends on decoding the command words in the question. And fourth, clear annotation. When it comes to Argand diagrams, annotation is literally everything. If you draw a locus, you must clearly annotate the key coordinates, the center of the circle, the exact radius, or the half-line angles. Without clear annotations, an examiner simply cannot give you full credit for your geometric representation, no matter how pretty the circle looks.
All right, Section 3, Problem Solving and Evaluation. Let's explore how the higher-order assessment objectives demand that you evaluate alternatives, compare approaches, and really justify your mathematical steps.
Stop scrolling! Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get into an interactive workshop mindset. Imagine I just put a massively complex mathematical data source on the screen, a dense paragraph with multiple complex constraints. If we had a 60-second timer right now for a data scan challenge, what would you do? Top-scoring candidates use this exact deconstruct, solve, evaluate framework. First, you deconstruct. You scan that dense text and extract the raw core trend. What is the actual complex number? What are the boundaries? Second, you solve. This is where you apply your analytical tools systematically in logical steps. And third, you evaluate. Actually, scratch that. You don't just evaluate, you interrogate your own answer. Does this final value actually make sense within the context of the Argand diagram? If you calculated an angle for a vector that is clearly pointing down into the fourth quadrant, but your mathematical answer is a positive pi/4, your evaluative check should immediately scream at you that something went wrong.
Think of this next part as a find the flaw challenge. You have to act like a strict mathematical analyst here. You evaluate the quality of your evidence by rigorously questioning these 4 specific elements. If I showed you a flawed sample paragraph from a student's exam, you'd use these to find exactly which sentence is losing marks. In the context of complex numbers, identifying limitations of evidence might mean recognizing that a particular locus only exists within a highly restricted domain. Questioning assumptions might involve double-checking your work. Did you just assume an angle was in radians when the question explicitly stated degrees? Or did you assume the principal argument shouldn't be negative? By actively considering alternative interpretations, you are bulletproofing your working against silly errors. You ensure your final conclusion isn't just a number on a page, but a robust, geometrically sound answer that is fully justified by your algebraic working.
Imagine we're doing a speed writing challenge right now.
You've got 30 seconds to mentally outline one perfect, high-scoring paragraph or mathematical proof. When facing an actual examination question on complex numbers, you follow these exact 4 steps sequentially. Step 1, you extract data. You isolate the variables and pull the given complex numbers out of the text and tables. Step 2, you select your analytical framework. You ask yourself, am I going to solve this algebraically by letting z equal x plus iy, or is it going to be way faster to solve this geometrically by sketching it straight onto the Argand plane? That decision is crucial. Step 3, you execute the calculation with pristine, undeniable step-by-step notation. Step 4, you present your final locus or coordinate points with absolute precision and correct terminology. If you follow this exact flow, you are literally speedrunning a perfect PEEL structure for mathematics. Finally, we are transitioning to Section 4, Top Examiner Warnings. We are going to take a very critical look at the principal examiner reports to uncover where students consistently, year after year, lose their marks.
This right here is the final system check. You need to avoid these 3 traps at all costs. The examiners literally publish documents every single year begging students not to do these things, and yet they still happen. Mistake number 1, confusing cause and effect. In complex geometry, this usually looks like a student totally misinterpreting the locus equation. For example, they might confuse the center coordinate of a circle with a point that just happens to sit on the circumference. It derails the whole question. Mistake number 2, forgetting to check format and presentation. Leaving an argument in degrees when the calculus or complex exponential form absolutely requires radians is just a tragic, heartbreaking way to bleed marks. And mistake number 3, answers lacking specific context. If a question specifically asks for the greatest value of the modulus of z within a shaded region on your Argand diagram, do not just give a generic algebraic answer. You must physically look at your diagram, identify the specific geometric point furthest from the origin within that exact region, and calculate it based on that visual context.
And this slide brilliantly illustrates our core unbreakable rule for this entire explainer. Show you're working. Method marks can save you. Even if your final calculation is totally wrong, demonstrating your systematic steps guarantees that you salvage crucial points. The examiners genuinely want to give you marks, but they cannot credit what they cannot see. If you're working out as scattered all over the margins, disorganized, or you try to do it all in your head to save time, you are walking on a tightrope without a safety net. By explicitly writing out your algebraic steps and sketching clear, well-proportioned Argand diagrams, you build an undeniable safety net of method marks. Show the chef your entire cooking process. To really ensure these procedural frameworks stick in your brain, I want you to try transforming these abstract concepts into a logical, visual narrative in your mind. Because Argand diagrams are inherently visual, you should use that to your advantage. Imagine a complex number as a physical journey. The real part? That's your number of steps east or west. The imaginary part? That's your steps north or south. The modulus is the direct flight path from your starting point, and the argument is the literal compass bearing you take. When you're dealing with loci, visualize a dog on a leash for a circle, or someone walking exactly down the middle of a road for a perpendicular bisector. This visual story method locks the abstract math deeply into your long-term memory. And listen, students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
As we wrap up this explainer, here is your final challenge. I challenge you to actively apply this deconstruct, solve, evaluate mindset to your very next practice session. Don't just passively read through your textbook. Grab a blank piece of paper, pull up a past paper question on Argand diagrams, and treat it like you are stepping into that MasterChef kitchen. Lay out your ingredients, execute your analysis methodically, and secure every single method mark by showing your pristine working out. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.